All right, hello, welcome to finals review day number 2. The focus is going to be on graphing, but before I do that, I had one simplifying radical question for you to try. If you're stuck on this, focus on like if you just were simplifying that square root of 150, how would you do that? So pause the video, give this one a shot. Okay, so the trick is to add them, you want them to be like radicals. So we're going to clean up just the square root of 150 because that breaks into the perfect square of 25 times 6. Okay, and same thing for 96. If you look for perfect squares, 16 evenly divides it. So I'm going to break that into root 16 times root 6. Okay, and you can see the point of doing this is now they're all going to be root 6, right? They all have root 6. So this would be 5 root 6s when I simplify square root 25, 4 root 6s, and then we have a single root 6 on the end. So if I add all those together, 5 plus 4 plus 1, that gives me 10 root 6 is my final answer to that one. Okay, so graphing is what we're going to review today, and there's all sorts of different types of graphs that are going to be on the test. Okay, so I'm just going to review them here briefly. If it has a square in it, right, we know it's going to be a parabola shape, right? So the squared ones are parabola shapes. Zoop, zoop. Okay, and then you just got to remember like the shifting idea. So like that's your base parabola, but this one would go, remember the inside makes us go left or right. So that one's going to make us go left by 3. And this one's going to make us go down 5. The end is up or down. So left 3, down 5, right? And then I just draw the parabola shape starting from there. Okay. If it has a fence post, it's going to be a V shape. Okay, so the second example here is a V shape. And the starting V just has a slope of 1 and starts at 0, 0. And again, we're going to use the same transformation. So it's the same idea that this plus 3 here is going to make us go left 3 because it's on the inside with x. Okay, and then the number up front, at least for these absolute value ones, is the slope. And so this one's going to be a slope of 2, but it's also going to be flipped over the x-axis because it's negative. So I'm going to go left 3, and then it's going to be flipped upside down with a 2 to 1 slope. I have a hard time drawing it here, but it's 2 to 1 going down. Okay, so that's what that graph would look like. All right, and then the next one here is the same graph, except now it's an inequality, right? So you'll have different shapes like U's and V's, but then you also have to watch for inequalities. So what would be different here would be the same things. I'd want to go left 3, and it'd be going down, the V would be going down. But then if there's no equal to here, we draw a dashed V. If there wasn't equal to, we draw a solid. And then the other part of inequality is you have to shade above or below. So a review of that is if the mouth is facing away from y, you go below because y is little. I always just think y is some small number, so you go below. And then if the mouth is facing y, you want to be above because y is big. So here we're facing away from y, so we're below, so we're going to shade inside the V here. Sorry, that doesn't look very good, but you're shading inside of there. All right. And then the last one here is just to point out that this one doesn't have a square in it or an absolute value, so that's just a straight line, right? So this last one would just be an inequality. That's just a line, and then we would do a dotted line because there's no equal to, and then we'd shade above it because the mouth is facing y. So this is our y-intercept number. Sorry, that graph is terrible. We'd start at 3. We start at a y-intercept of 3. And then our slope would be negative 2 to 1. So I want to go down 2 and right 1. Down 2, right 1. Okay, and then again, we're going to draw a dashed line here because there's no equal to. And the inequality, the points on the line don't count essentially. So there's our line. And then we're going to want to shade above because the mouth is facing y. So we'd shade it above like that. Okay, so on this test, you'll see all sorts of different things. You'll see lines, V's, U-shapes, parabolas, and then sometimes there'll be inequalities, sometimes there'll be lines. So those are all the different things you got to watch out for. All right, so a big summary of this would be the parabola shape. So if you wanted to get one more summary thing here, This is just the straight parabola shape, right? Looks like that. That's the basic one, starts at 0, 0, and then all of these parts transform. So I'm going to have you pause the video and see if you can label how to, the H, the K, and the A, how does it affect the parabola. Pause the video and give it a shot. Okay, so the K will move us up or down, and it's kind of normal. So sorry if I can do this right. So it's going to move it up if it's positive. So like +3 would go up 3, down if it's negative. So something like -4 would make us go down 4. And then if it's inside with x, it's going to go left or right, opposite of what we think. So left would be something like, instead of subtracting, it'd actually be add. So x plus 2 would make us go left 2. And then right would be something like, well, sorry, that did not work well. X minus 4, that would make us go right 4. Okay, A is probably the hardest part of this. It can do a few different things. It can stretch. So multiplying with the quantity up there, that can stretch it, and that'll happen if A is bigger than 1. It'll compress if A is a little decimal or a fraction, so something between 0 and 1, so like 1/3 or 0.4 or something would make it compress, and then it can also make it reflect. Okay, and basically if it's got a negative in it, like a negative value is going to make it reflect. And we'll talk about over X or Y axis. So that's a summary of transforming this particular parent function. Okay, so the rest of this is just going to be review questions, which I'm going to have you pause and try. So we've got a linear one here, and we want to go over the x-axis. So see if you can figure out what would be the right equation. And if you're not sure on this, I always think draw it out is a good plan. So I'll probably do that here in a second, but try it first. Okay, so if you can memorize it, the trick is to reflect over the x-axis. You want to take the whole thing times -1. So I'm going to do -1 times 2x plus 3. So that would be -2x minus 3. And if you ever want to reflect over the y-axis, I know that's not what's being asked here, but if you ever want to reflect over the y, you just do the -1 times the x part. So on this one, you just take -1 times just that front part, so it would be -2x plus 3. Okay, and so if we want to verify that, and I'm kind of wondering now, I'm not sure if I got it right, but I can verify it because I can graph this one quick. So that would just start at 3 and have a slope of 2. I could draw the line. All right, and then I'm going to draw the other line. Like this is the one I thought is the right answer. So I'm going to draw that and see if it looks like it's reflected over the x-axis. So that would be at -3 and have a down 2/1 slope. Down 2/1. So it would look like this. So when I look at my answer, it does look like the original line got flipped over the x-axis to give us this equation. So that's sort of a way I can verify that my answer is right, is just looking at it graphically. So you can memorize this, that the whole thing times -1 for x-axis and just the x part for the y-axis, or you can draw it out. Okay, just different questions. So it's all based on the same graphing stuff that we reviewed at the beginning, but there's a different form of a question. So what would be the transformations here? We're starting with x squared, and we want to know how would this one be different? How would g of x be different? Okay, so hopefully you had a chance to try it. I'm just going to label the parts. The -7 would make us go down 7. The +3 there makes us go left 3. Okay, and then the -1 in front, that's like the whole quantity times -1, so that's going to make us reflect over x-axis. All right, and that, if the negative was on the inside with x, then it'd be over the y-axis, but because the whole thing's times -1, it's going to reflect over the x-axis. Okay, this is going in reverse. Now they're going to give us the transformations, and we're going to start actually with the cube function, but it really doesn't matter what the parent is. What would it look like after these transformations? Okay, so the way I do this is I kind of just fill in, there could be an A number, there could be an H, and there could be a K. So I just kind of fill in these blanks. So here, a stretch of 7 is a multiply with 7. 7 units right goes inside of here, opposite of what we think. So right would be -7, and down 5 would just be a -5 in the back. So just fill in the different parts, and you've got your equation. It doesn't really matter what the parent is, right? It's the same A, H, and K values all the time. Okay, so now actually making a graph. So you got to think, is it an equality? Is it a U? Is it a V? Think through all those things and try the graph of this before continuing. Okay, so first thing I would think here is this is a V, and specifically it's a 2-slope V because of this. It's got a stretch in it. And then this makes us go, let's see, not left, but right 1, and then this is going to be up 4. Okay, so I'm going to go right 1, up 4, and I'm going to draw a 2-to-1 V going up. It's going to look like that. It barely fits on my graph. It goes like that. And then I'm going to think there's no inequality symbol, so I don't have to do any shading or dash lines or anything like that. That's just it. Just draw it, right 1, up 4, with a slope of 2. Okay, next one, give it a shot. This one again is a V because of the absolute value, and then it's got an inequality. So this would make us go left 4 and up 1. So I'm going to go left 4, up 1. It's got the regular 1-to-1 slope. So I'm just going to draw it going down, but I got to remember to draw a dashed line because there's no equal to here. A dashed line, I guess I should say dashed V, and then I'm going to shade below. Right, because the mouth is facing away from Y, it's below that V, so I want to shade down here. So that one's an inequality where you've got to draw a dashed line and then shade below. Okay, again, just another one for you. I'm mixing them all together, and again, think through what shape is it? Do I got a shade for inequality? All those things are, I'm just going to leave them up to you to think. Okay, so this one's our parabola shape, and it's going to be moved left 4, and this makes us go up 3. And then these really don't have a slope because it's not a straight line, it's a curve. So this is just going to be a compression, again in the vertical sense. So it's going to be compressed like that is the way compressions look. They get smushed vertically, and then it's going to be flipped upside down because it's negative. So it's going to reflect over the x-axis. So reflect over x-axis. Okay, so now I just got to draw all that. So I'm going to go left 4, up 3. Okay, and then I'm going to draw it compressed and reflect it over the x-axis. So I'm going to draw it looking something like that. That's not a great graph, but hopefully that gives you the right idea. Okay, and I just wanted to mention real quick too, you can use your calculator to help, right? So if you have access to a graphing calculator, that's real big help on this test. So I'm just going to show you how to graph this particular example. So basically, you go into y equals, and all of them are mostly the same. You want to clear this out. Make sure all the plots are like this, they're off. If they're on like this, you need to turn it off. So go up there and turn it off. And then just type it in. So we've got -1/2, so I'm going to do parentheses, negative sign 1 divided by 2. Then I'm going to do another parenthesis. It was x variable, and I forget already, but it was x variable plus 4 squared. X plus 4 quantity squared. And then on the back, it should be a plus 3. Plus 3. And then I'm going to see if I get what I expect. So we've already graphed it out here, but I want to verify that my answer is right. You can see that's pretty much right. The shape is slightly different, but it gives us in the ballpark. So it's just a way to kind of check using the y equals screen to make sure we got it right. And if your graph doesn't ever have this window, remember you can hit zoom, and zoom standard number 6 will get you back to the standard window if that ever gets messed up. So that's it for graphing review. Remember, there's lots of different types. You just kind of got to think it through on the final. Thanks for watching.